Hello everyone. Welcome to Enzyme MBBS, where complex medicine becomes simple and exam ready. Okay, so without wasting any time, let's get started. Coming to the introduction, wound healing is a highly regulated, complex biological process by which the body restores integrity of injured tissue. The process of wound healing occurs through coordinated interactions between cells, extracellular matrix, growth factors, and cytokines, ultimately resulting in restoration of tissue continuity and function. So both the sentences are self-explanatory. The thing why you write this in the initially, because that heading basically gives the impression for examiner that okay, he's writing it in a formative, in a good format. So that's the only reason we write it. So next, coming to the basic principle, healing occurs by two ways. Okay, one thing is regeneration, one more is repair. Regeneration is basically replacement by the same type of cells, whereas repair is basically replacement by connective tissue. So depending upon the extent of injury and few other factors, it determines whether the wound will be healed by regeneration or repair. Now coming to the skin, wounds heal predominantly by repair with scar formation. Then steps of wound healing. So here I have given you the flow chart before, and the each point that is mentioned in the flow chart we are going to see it in detail, but before that we just need to write an entire process superficially so that examiner can come to know that okay, you know the process. So it is tissue injury first happens, then hemostasis happens, then inflammatory phase, then proliferative phase, which is basically granulation, tissue formation, epithelialization, and wound contraction, and maturation and remodeling phase. Don't worry, we are going to see each phase in detail. So coming to the first phase, that is hemostasis. Time period when it occurs, it begins immediately after the injury. What are the events that happens during this phase? It is first rupture of blood vessels takes place, so bleeding happens, because of that platelet aggregation happens, and then formation of fibrin clot. Eventually we say it as scab. So what are the functions of this? One thing is it stops bleeding, and it serves as temporary extracellular matrix, because later of course we are going to produce new extracellular matrix, but for time being it serves as temporary ECM. Then it acts as scaffold for inflammatory cells, fibroblast, and endothelial cells. What do you mean by scaffold? Scaffold is something which is a temporary structural framework, because extracellular matrix basically gives you the main structural framework, but for time being it acts as a scaffold. So that is what it basically means. So scaffold for which? For inflammatory cells, fibroblasts, and endothelial cells. What are fibroblasts? Fibroblasts are basically the cells of connective tissue which basically helps in the production of extracellular matrix. We need new extracellular matrix like collagen, so fibroblasts are going to help us in producing that. Then scab forms a barrier on wound, preventing microbial invasion. What are the factors involved here? It is factor 13A, activated, A means, and TGF alpha and beta. TGF is nothing but transforming growth factor, and PDGF, which basically stands for platelet derived growth factor. Next, coming to the inflammatory phase. Now, inflammatory phase, it begins 1 to 3 days after the injury. What are the events happening here? Basically, cellular events happen. So, first thing, neutrophils, they are the first cells to arrive, and they basically phagocytose necrotic debris and bacteria and produce proteases. Whereas macrophages, which is the key cell of this phase, it is derived from the monocytes, and they are the central regulators of healing. Now, coming to the functions of phagocytosis of neutrophil debris, because neutrophil have arrived first and they have already eaten the necrotic debris and bacteria. So now their work is done. So we have to remove them. Though, so their phagocytosis happens. Then they basically secrete the growth factors, important growth factors, that is VEGF, PDGF, and TGF beta. What is VEGF? Vascular endothelial growth factor. PDGF we discussed, TGF we discussed. Then activation of fibroblast and endothelial cells. Obviously we need the activation of fibroblasts, because the next thing we are going to do is production of extracellular matrix. Now coming to the proliferative phase. So this is the most important phase of wound healing. Okay, so time, it starts from day 3 to 5. Then first thing that happens is formation of granulation tissue. Now what is granulation tissue? Granulation tissue is the transient specialized organ of repair. What is transient? Transient is something temporary. Remember, in vascular events we said during first phase before vasodilation there is a transient vasoconstrictions, means it lives for only a short time period. Okay, so that's why I said transient specialized organ. The specialized organ is present for only few time. I mean small amount of time. So it is characterized by numerous new capillaries, proliferating fibroblast, and loose extracellular matrix. So these are the characteristics of granulation tissue. What are its components? First thing is it helps in angiogenesis. So angiogenesis is nothing but formation of new blood vessels. So it is driven by VEGF and FGF2. Now VEGF, you know, vascular endothelial growth factor. FGF2 is fibroblast growth factor 2. So it supplies oxygen and nutrients. Next, fibroblast proliferation. So fibroblasts migrate into wound stimulated by PDGF and TGF beta, and it begins the collagen synthesis. As we discussed, fibroblasts are the cells of connective tissue which basically helps in the production of extracellular matrix. Next, ECM deposition. So initially fibrin and fibronectin is deposited. Later it is replaced by collagen type 3. Next, collagen synthesis. So it begins around day 3 to 5. So type 3 collagen deposited first. So it requires oxygen, vitamin C, and adequate nutrition. Why vitamin C? I hope you studied in the first year biochemistry that it is a cofactor for the enzymes which are involved in the hydroxylation of collagen. Like it basically helps in the production of hydroxyproline and all those things. So vitamin C you require for this particular process. Next, epithelialization. What is the process of epithelialization? So first thing is migration of epithelial cells from wounded edges, and it occurs over granulation tissue. What is the mechanism? Loss of contact inhibition. Now few of you may have doubt what is contact inhibition. So generally what happens when a cell is dividing, as soon as it comes in the contact with another neighboring cell, the division stops. So that is basically contact inhibition. But now during epithelialization, we need the cells to divide, we need more cells to cover the wound. So during that phase, for a temporary time, the contact inhibition is lost, so that it can divide and cover the wound. Next thing is basal cells proliferate and migrate. What are basal cells? If you study the layers of epidermis, there is something called as stratum basal. So the cells of that particular layer is nothing but basal cells. So they act like stem cells. They divide too much. So there they proliferate because as we said, we need cells to cover the wound. So there they divide, they proliferate, and then they migrate. So that is what basically happens. And then re-establishment of basement membrane. What is basement membrane? I hope all of you are aware of it. It is present between a epithelial cell layer and a connective tissue. So that's the thing. And then importance, it restores the epidermal continuity and prevents infection and fluid loss. The next phase is wound contraction. What is the mechanism of it? It is done by specialized type of fibroblast called as myofibroblast. Now myofibroblast contain actin. The name itself says myo, something related to muscles. In muscles, actin, myosin you would have studied. So myofibroblast contain actin which has contractile abilities. So multiple myofibroblast form tight junctions and contract. So they pull the wound edges together. Significance of this is it reduces the size of wound. So it is more prominent in large wounds. When large wounds happens, the wound contraction is necessary. Of course, in small wound size, it may not be that significant, the wound contraction phase, but of course it is prominent in large wounds. Next, coming to the maturation and remodeling phase. So it begins after 2 to 3 weeks and continues for months to years. Depends upon the extent of injury. Now, events in remodeling, what happens? So first thing is collagen remodeling. We discussed before that first there is fibrin and fibronectin, then collagen type 3 comes. But collagen type 3 is not that much suitable. We need collagen type 1 because collagen type 1 is more, it has more strength. It provides more tensile strength. What is tensile strength? Tensile strength is the strength which a completely healed wound can withstand without breaking. So we prefer type 1 collagen for more tensile strength. So for that we need to change the type 3 collagen. For that there will be some enzymes called as matric metalloproteases which are majorly provided by fibroblast. So it contains collagenases, gelatinases, stromalysins. So all this help in degradation of fibrillar collagen, amorphous collagen, and basically they will remove that collagen type 3 and later it is replaced by type 1 collagen. So collagen fibers reorganized along tension lines. Next, coming to reduction in cellularity, after this apoptosis happens. Apoptosis of what cells? Apoptosis of endothelial cells and fibroblasts. Then vascular regression, that is decrease in capillary density, and scar becomes pale. So this is the whole process of wound healing. Then you have to mention few more points. That is, one thing is tensile strength of healed wound. So we discussed about tensile strength. So what is the value of it? So in the first week it will be approximately about 10%. In 1 month it becomes 40%, and in 3 months it becomes approximately 70 to 80%. But note that it will never reach 100% of original strength. Whenever wound happens, the tensile strength keeps on decreasing. Next, role of growth factors in wound healing. We discussed many growth factors while discussing this video. So just mention all of them at one place and write their main functions. So growth factors are PDGF, that is platelet derived growth factor, TGF transforming growth factor, VEGF vascular endothelial growth factor, FGF fibroblast growth factor, and EGF endothelial epithelial growth factor. So their functions: PDGF fibroblast migration, TGF beta collagen synthesis, VEGF angiogenesis, FGF endothelial proliferation, and EGF epithelial regeneration. And last but not the least, mention the clinical significance, that any defect in these steps leads to delayed healing, chronic ulcers, and excessive scarring. This thing we will discuss more detail in another video, which basically speaks about the complications of wound healing. And also mention one more point, that understanding the process of wound healing will help us in surgical planning and management of chronic wounds. So that's all for this video. I hope it was helpful for you, and study this well and write it in the exams, get the marks you deserve. So that's all for today. Thank you so much, and keep studying, keep liking, and do comment the video. Yeah, all the best. Thank you.